Hi, welcome to Processing in Video. Here we're looking at how processing can deal with video streams, both from your webcam and from movie files on your computer. This week's work is called Bot and Dolly, and you can have a look at it at that Vimeo link there. This is a really interesting work made up of a robot arm holding a large white board, actually I think a couple of robot arms, alongside a projector which projects onto those boards, giving it a really dynamic look and feel. So this week we're looking at getting video into processing, manipulating video streams when they're in processing, and real-time video analysis with OpenCV, Open Computer Vision it's called. So what is video? Video is basically a series of still images presented one after the other at a rapid rate, and if we have enough speed, 15 frames per second for instance, we start to perceive continuous motion. Most video streams are around 24 frames per second or 30 frames per second if it's a movie file, and if you're dealing with computer games, of course, they can be a bit faster than that as well. But the magic number is pretty much 24 frames per second. We need that to have a fairly smooth video stream. Processing provides two main objects for working with video. There is Movie for loading and playing video files, and Capture for accessing video streams from cameras. So if you want to just load and manipulate a video file, you'll use Movie, but if you want to use the camera on your computer, you need to use Capture. If you don't have a camera on your computer, or you haven't connected a USB camera of some type, then Capture won't be able to find anything to capture from and will error out. So here's an example of some code for processing video. In the setup, we create this new movie with a path to the movie file. Then we say movie.loop, and we have this movie event which is called every time a new frame is available. It just reads that frame. The main work is done in the draw command, as usual, where we simply state where we want to draw the movie. We say image, movie, the location of the top left corner of that movie, and the width and height, just like we do normally with every image. But instead of referring to a P image, in this case we're referring to a movie. And we're going to get the image that is appropriate at particular times. So that image is going to change. So let's have a look at that. I'll open up Loop. So here is the code. Notice we've got a global movie here. We can access that anywhere. We set the size in the background. Then we load our movie. Now if you have a look at this, you'll have a data folder with the movie file in there, inside your sketch folder. Then we have the movie event, and then the draw command. So let's run that, and we see this movie file run. So we can look at this movie file directly in the folder and see what's happening. So it's a pretty standard movie file. Movie has a number of methods for manipulating playback, such as you can change the speed, you can set loop or no loop, and you can pause the file. So let's take a look at that. So here you'll notice we have set loop, We've got the draw, everything else is the same about this part, but now we've got a pause command if the mouse is pressed, a play command if the mouse is released, and we can change the speed with the key 1 or 2, and we can go in reverse with the key R. So let's try it out. So if I click, it pauses, and I can pause as many times. I can set the speed by pressing 2, and it doubles the speed. 1 is back to the normal speed, 2, 1, 2. And I can press R to go backwards. I got a crash. Let's try that one more time. Looks like the change in the movie underlying code, we've moved to GStreamer here, has meant that we can't use the negative values that you used to be able to. So let's set that to 0.5 and see if we can get that to work. So we can still do slow motion if we wish, but we can't go backwards anymore. Because each frame is an image, we can apply image processing methods to each of those frames. So we can do the same types of things we were doing with images with frames of video. Movie is a subclass of image, so we can manipulate the pixel buffer if we want to, and we're going to by pixelating, as we've done before. So you remember the example we did where we pixelated the image of the woman. Here we've got the pixelate example here. We're loading the same movie again, but in this case we're going to work through doing pretty much the same thing we did with that other image pixelation example, working through the pixel buffer. Notice we've done load pixels here, and we're drawing directly to the screen here. We're doing rectangles. We're not reloading the pixels as we did. So there you go. We've got pixels with a block size of 10. We can change that to 20 if you like to see larger pixels. There we go. Very similar type of thing. To get a video directly from a camera, we use the capture method. Methods include list, because if you have multiple cameras, you might want to see which ones are which. Read, and start and stop. So let's have a look at that. So I want to load video, which is here. So we say capture, not movie, capture vid. Size, new capture to initialize the camera. That basically makes the connection to the camera, and that's where it'll fail if there's no good camera to connect to. Then it says start to start that connection. Now here we are reading from the connection and drawing the output of that connection by using the image command, like we did with the movie. So let's try that out. Hi. Again, because we've got an image that we can look at the pixels for, we can manipulate the pixels in exactly the same way as we were doing with the video file. So let's have a look at mirror. Whoops. I'm going to show you mirror and mirror 2. So this one changes the look of the images into moving shapes. You can see we have a very similar thing here, but in the draw method we've got load pixels, and then we work through each of the pixels and we decide a few values, and then we use them for rotation based on brightness, fill based on the color, and we cut out the stroke around each of the shapes, and we draw rectangles, lots of rectangles. Okay, so we can do that. That's a lot of rectangles being drawn very quickly, so we can do some interesting things with videos. Mirror 2 is pretty similar. But in this one we're drawing a different size of rectangle based on the brightness of the color. So if you look at the code here, you can see again we're working through columns and rows. We're looking at the color here by looking at the video, the pixels of the video. We're working something out based on brightness times cell size divided by the brightness's maximum, which is 255. And then we're drawing a rectangle based on with a particular size there. So that's another interesting effect created from a video image that's changing all the time. So using real-time analysis, we can have a look at the image and try and track movement through the screen. So we could do things like tracking the brightest pixel and or doing background subtraction. So let's have a look at background subtraction. The good thing about background subtraction is you can look for change rather than looking for things within the space. You can do you can assume that everything will be the same except the things that are moving, kind of like a lizard does. See, here we've got an example of background subtraction. We need to initialize the background subtraction by pressing a key, and now all you'll see is things that are different from that original position. So if I can pretty much, I can press a key again, and only if I start to move do you see that difference. If I get out of the way. So this can be an interesting effect, can be very useful for finding moving elements within your screen and then tracking them. OpenCV is a library, or actually a set of libraries for image processing and analysis. It's been developed over a long period of time, and it's a really popular choice. It can be good for tracking movement, for tracking faces, and for edge detection and other image manipulations. So it's a lot more powerful than what you can do with processing. It's the mathematics involved with doing these types of things is quite extensive, but OpenCV wraps it up for you and makes it usable in your sketches. So I'll show you edge detection and the live cam test. So to use these you need to load the OpenCV library. I'll show you how to do that. So live cam test is here. This is actually face tracking. To load the library, you go add library and you choose OpenCV here and you get OpenCV. I've already installed it, so I don't need to. It's quite a big library. It'll take a little while to install. Here we have face detection. I'll just change my camera. So you can see my face is being tracked within the screen. So you can work out how many people are looking at your camera. And the other one is edge detection. So here there's a number of different ways of processing an image and looking for edges within that space. Have a look at the code here. You'll see different methods of finding the edges being applied here with their own sets of parameters. So each of those creates a separate image, and we draw each of the images in different locations, and that's why you're seeing the original and then all the other methods of finding the images. So OpenCV is huge and extremely powerful. If you've got time, have a look at that. It's really a useful approach to processing videos. So hopefully you now have an idea of how to understand and play and manipulate video. You're able to read and display live video streams from your webcam. You understand the basic concepts of video analysis and have an idea of what OpenCV is for and how to use some basic features in processing. So thanks very much. This is the last week in this semester, so I hope you've enjoyed learning about processing and learning about interactive media.